Drainage water recycling system has two benefits. The first benefit is improved crop yield and reduced yield variability from year to year. The second benefit is improved water quality.
Drainage recycling is basically taking several practices and putting them into one, and I'll list that. So you have a subsurface drainage system, then you have a pumping plant to harvest the subsurface water, and then you have a pond or a reservoir to store the water, and then you have a irrigation pump to pump the water back to irrigate it.
The initial motivation for the need for the project was achieving a drainage outlet for the farm. We had to explore different ideas of what we could do for, first of all, draining the field. And then one thing materialized to another, and it turned into a drainage and irrigation project, which turned out to be a pretty exciting project.
The system that was created at the Brian Gates farm was fairly simple. He didn't have a tile outlet. He hasn't had a crop on this farm in 3 years. In fact, the last crop he had, the wheat went like 59 bushel, where we typically grow 115 bushel wheat. It needed to be tile drained. That was the first item. So his thoughts were build a pond just to harvest the water, and he really kind of thought he'd harvest the water and just let it overflow, and then you'd pump it out into the ditch. After talking, he said, well, you're putting all these tile in there at 20-foot spacings. Why not try to set it up as a sub-irrigation system with, again, controlled drainage, pumping plants, storage, and complete the cycle. Because of the Western Lake Erie Basin, there's all kinds of grant money to do projects, and we wrote a small grant from the GLC, and they contributed $50,000 towards this project, and the Nature Conservancy contributed $20,000. But the total cost of everything on here approaches $400,000. Anytime you start to dig dirt, you have certain rules and regulations, and every state, every township can be different. In Michigan, under a permitting process, agriculture is exempt if it's for agricultural use, unless they build a pond that's bigger than 5 acres in size and has a water level that's 10 feet above the ground. In this case, we're 4.9 acres, and we only have 8 foot of water above the ground. We have 8 foot below and 8 foot above. So we don't meet the criteria for needing a permit under the state of Michigan. 0 to 1% slopes. It's typically fairly flat. Deep county drains for subsurface drainage systems. Clay, loam soils, 40% clay. Very, very productive when they're tile drained, and the spacing ranges anywhere from 50 to 20 feet on these soils. The reservoir at the site is really the key. It's the most expensive part of this project. To build this 5 acre, 16 foot deep, there's about 2.5 million cubic feet of water, or about 20 million gallons of water that we're storing. It's the outlet for the pumping plant that takes the water from the subsurface drainage system and provides the outlet. So this is how this works. You have 3 main tile on this site here. They all go into a pumping plant, okay? That pumping plant, in this case, has a pump that pumps over 1,000 gallons a minute. That's how much water we're gonna have coming here when this system is flowing full. So in an ideal year, if we've had the normal rainfall we've had and it hasn't been dry, the pond should be fairly full at the end of May. Brian Gates on this farm originally was going to harvest the water with a pond, but he wanted to put a center pivot irrigation system on this field. A sub-irrigation system, we're able to use the existing tile system that are here. So the tile are twofold, drainage, and then they also provide the storage area to saturate the soil for subirrigation purposes, okay? The increased cost for subirrigation is just having a pump plus transmission lines. We have two 6-inch transmission lines that are pumped to the end of the field. And so that cost is far less than a center pivot irrigation, okay? We topo surveyed the site, and we were able to plot that on paper, and it would identify exactly where we could identify our 1-foot zones. And so knowing where our pipelines were, we drew on paper where the main tile go, where our 1-foot zones go, and then once we had that on paper, we could identify where our control structures go. I will say this, I have 24 instances of this design, so you just don't get it done in one time. Because once you get a basic design, you take it to the contractor, you take it to the farmer, and they tweak that and make it better. So we had to have the pond done first. So, because if we were to put the tile system in, okay, what do you do with the water? It's just going to flood out these, and the water's going to run down the field. So we had a wet fall, but we were able to get the reservoir, or the pond, the 4.9 acre pond, installed last fall. Took about 6 weeks to get that installed. Could have been done quicker, but we were in between the raindrops. And then the tile main system, there's 3 mains, were installed last fall by Don DeYoungie, the contractor.
Tom started out with a plan, and they RTK'd the field, so we knew the elevations and stuff. And so we laid it all out, and then when we got here and got in touch with the 3 pipelines that run through the property, it changed everything from what we originally wanted to do. So we had to move a main behind the pipeline because it was too shallow, but we took it up to the road where we could cross because it was deeper up there where the pipeline crossed the road. And basically getting over the other 2 pipelines, we got as deep as we could be. It worked out okay.
The 1,000-gallon-minute pump was installed this spring with the electrical system. It has a 3-phase converter that was put in, and he's got a little bit of electrical work to be done at the road, and the pump is ready to go. We do have an overflow for safety reasons if the water gets too high, but the primary use of the water is going to be to take that water and sub-irrigate it back to the field. There are 16 water control structures on this farm, and when you sub-irrigate, you like to set up management zones on 1-foot difference in elevation. Well, because there's like 7 feet of fall from one end to the other and 3 separate mains, we needed that many control structures to be able to manage the water. So we're going to have a floating variable rate pump that pumps the water from the pond to the upper end of the field, and the water will stair step down caused by the control structures, creating water table in the field 18 to 20 inches below the surface. And we know where that water level is because we can look down some of the control structures and see.
The idea is going to be to keep every bit of water that falls on the farm, and it should leave in the form of a crop that leaves in a truck. But there is possibly going to be some challenges there with the different weather patterns. Implementing this system should help with the traditional corn and soybean rotation as far as increased yields, both through the improved drainage and the irrigation aspect of it. And once we get the field in full production and see the capabilities of it, maybe the possibility of exploring a specialty crop like seed corn production or sweet corn production or a different specialty crop like that.
But I think we can take a system like this and with the technology and really move it to higher level type cropping systems to make it applicable. I'm not sure a lot of farms would say, okay, if you do the ratio, this is a 110 acre farm, so I need 5 acres for every 105 acres, right, to take out of production. How do I recoup the crop loss? And that's one of the things we're going to do here. We're going to evaluate the economics of this and see where it can apply from an economic standpoint on other fields around the area.
So the research is going to benefit the public because it's going to inform the public how the system is going to affect their bottom line, and that's going to be the crop yield. And also the public is interested in the water quality aspect of this too. And if we can show that it reduces nitrogen and phosphorus coming from subsurface drained fields, then it will have a lot of value.